Hi ladies, today I'm just going to do the bone experiment for those who weren't in class. So I'm just going to switch and move my camera a bit so that you can see what I have over here. Okay, so over here I have a bottle with water in it and the bones inside, and then bottle B with vinegar and the bones inside. Now we started this experiment before lockdown, so these bones have been in vinegar and water for much longer than the 1 week that they said we should do it. This experiment is on page 20 of your textbooks. Okay, right. So just to show you, okay, page 20 of your textbook. Okay, so I have the 2 jars, then I have 2 plates, okay, labeled A water, B vinegar, okay, then I have some disposable gloves, because after a few months they smell quite badly, especially the one in water. All right, and then I just have a container here with a jug of water, or a container of water, that I'm just going to rinse the bones with. Okay, so I'm putting on my gloves, and then I am going to remove them from the buckets, from the jars. Okay, it's, oh my goodness, start with water. Okay. Ooh. Oh my goodness. All right. Oh, for this part, I'm actually going to put on my mask because it smells phenomenally bad. Okay, so I'm just going to use a fork and I'm going to gently lift them out. Okay. Oh my goodness. Okay. Right. Okay. Then I'm just going to bring this closer, and then I'm just going to rinse them so that they are nice and clean. Okay, they smell extremely bad. Okay, and that's water, so I put them on the plate, A water. Okay, this jar has been closed, but it smells really, really bad. Okay, close that up again. Now I can take off my mask, and then let's remove the one in jar B that says vinegar. Okay, you'll see, ooh, some of them are floating at the top. I put in more than the one bone that they said we should. Okay, and they just smell like vinegar. They don't smell bad. Well, they smell like vinegar. The others actually smell rotten. Okay, right, so, okay, so here we have bones from vinegar, the bones that were in vinegar and the bones that were in water. So what we have here is the ones that were in water still have calcium in them. The ones who were in vinegar do not have calcium in them anymore. Okay, right, so I am quickly going to switch you guys to my other camera. Okay, right. So over here we have the paperwork that we will be using. Sorry, let me switch on the lights for us. Yes, that's better. Okay, so this is all I've done, is I have basically typed out the stuff that is in your textbook on page 20. Okay, this goes hand in hand with your these scientific method notes. Okay, this is where I explained what is the scientific method. The scientific method consists of several steps that you follow. The first one is you ask a question. Okay, a question the answer can never be only yes or no. It always has to be an explanation. Okay, for example, what happens when, how does, why does, or just why. Okay, so there are some examples. Right, so the first one, back at our experiment, we say we are going to investigate what happens to bones when calcium is removed. In this investigation, you will find out what happens to bones if calcium is removed from them. We use vinegar to do this because vinegar chemically reacts with the calcium and removes it from the bones. Okay, so now we start with our question. Okay, so that is our topic. Our question is, what happens to bones when calcium is removed? So that you write down over there. Then we write our hypothesis. Now here again, I refer you back to these notes. Okay, what is a hypothesis? Okay, a hypothesis is your prediction or your answer to the question, what you think will happen in the investigation. Okay, here we have an example where we say, how does the temperature of water affect the rate at which sugar dissolves in it? Okay, and then we can say sugar will dissolve faster, but that's not the proper way of writing a scientific hypothesis. So we rather say, if the temperature of the water increases, then the sugar will dissolve faster. By writing it like this, we use the writing frame that says, if I do this, which is the independent variable, then this will happen, the dependent variable. Okay, right, so there you write your hypothesis. Okay, remember, you think, I think, but you don't write it down. You start with, if I remove calcium from bones, then the bones will become soft and flexible. Or if I remove calcium from bones, then the bones will stay hard and strong. Okay, so there you write what you think will happen. Next, we go to step 3, which is to plan and carry out our investigation. Step 3 consists of 2 parts. 3.1, where you have to write a list of materials and equipment you will need, and 3.2, which is a method, which is step-by-step instructions. Okay, so over here, we look at which materials and equipment we needed. Okay, now just to refer you back to our textbook. All right, so materials is we will need 250 milliliters of water, 250 milliliters of vinegar, and at least 2 cooked and cleaned chicken bones. Those are our materials. Our equipment is everything else that we will need. Everything else that you have seen me use in my explanation. Okay, so we had 2 jars, the 2 jars in which our bones were. Okay, I had gloves, and I had 2 plates that I put it on, and each plate had a label. So I had 2 similarly sized jars, 2 small plates, labels, and disposable gloves. Okay, right, so you write that there. Then we go to the next page. For this activity, I have been nice. I have typed the method, the instructions for you. This is what we did together. The book also gave them to us. Okay, now in any experiment, we need to be able to compare our results to something. And that is why we have something called a control. Something that we don't do anything to, so that we can see whether our results, whether what we did changed it or not. So in this case, we had water, which was our control. Remember, the bones that had water in them, or the bones that were in water, right? Oops, sorry, vinegar, in water, still have calcium in them. The calcium has not been removed from these bones because water does not react with the calcium in bones. But the bones that were in vinegar, here the calcium has been removed. Okay, so what we have is bones without calcium, bones with calcium. Okay, let's see if I put them like that, whether we can get them into the picture. Okay, right, so in this question, number 1, which jar was the control? The purpose of a control jar is to have something to compare your results. So that was jar A with water, because we want to see what do bones, we want to compare bones with calcium with bones without calcium. Okay, right. Then why do we need a control? Because we want to compare. The word compare is very important. Bones with calcium with bones without calcium. Okay, then the third one says, do you think this was a fair test? Right, so you'll remember that in this test, we kept everything the same. Similarly sized jars with the same amount of liquid in them, 1 vinegar, 1 water. We left them in for the same amount of time. The jars were next to each other in my storeroom. So it wasn't the one was in the fridge and the other one was in the sun. And then we kept all of those things the same chicken bones, similar chicken bones. The only thing we changed was the water and the vinegar. So for this answer, it's for 4 marks. You need to tell me, do you think it was a fair test? Yes or no? Your first answer, your first mark. And then give 3 reasons. Give 3 reasons, okay? Now, in order to have a fair test, it means we changed only one thing. We kept everything else the same. And in the end, we had bones with calcium as a control. And we compared them to bones without calcium in jar B. Okay, right. Then in class, when you looked at the bones and you touched them and everything, you completed a little table that asked you describe what each bone looks like, describe what each bone feels like, and then draw a sketch. Okay, so this is what this table looks like. All right. So in here, you recorded your results. Right, now I'm going to try and demonstrate to you guys what you would have seen and felt in class. So let's start with the bones in water, okay, which are these. Okay, so their color hasn't really changed much. They still look like normal chicken bones. Okay, so light yellowish with a bit of red, okay. All right, and then okay, they smell really bad. But if you look and I try and bend it, okay, they are hard and rigid. Okay, they are hard and rigid, all of them, okay, are still hard and rigid, just like you would expect a chicken bone to be. Okay, so there you write, what do they look like? What do they feel like? And you make a little sketch of a bone using color. And you can add labels to describe and show what these bones look like. Okay, so they pretty much look like normal chicken bones. Then we move to jar B, the bones that were in vinegar. Okay, right, now something to notice is, for example, look at this one. You see it's all cracked and, right, it looks like they're almost coming apart. Okay. Look, I can squeeze them. Look, it is soft and flexible. Just look at that. Okay, so these are bones without calcium. Okay, and once the calcium has been removed, the bones become soft, spongy, and flexible. Okay, soft, spongy, and flexible. So there you have bones that have been, and you can see that the color has changed, right? They're a very dark gray now. Let me put these back so that you can see the two next to each other. Okay, so that you can draw and compare them. Okay, right. So these you will then draw as bending. Okay, that's how you will draw it to show that they bend. Okay, this one, no bending. I'm really pushing hard. If I push any harder, I'm actually going to break it, but it won't bend. But the ones without calcium are flexible and really soft and squishy. Okay, right. Okay, so next, you record your information. Then step 5, we draw conclusions. A conclusion tells us what you found in your investigation. So here I help you guys by asking a question. What does this investigation tell you about the importance of calcium in your diet? Okay, this is for 2 marks. I'm sorry, just make a little change for me there. This one is for 2 marks. Okay, this one is 2 marks. All right, so what does this tell us about the importance of calcium in our diet? This is what bones, A is what bones look like with calcium. Nice and strong, okay, and hard, so that it can give our body shape and support our weight, and very important, for example, your skull and your rib cage to protect your vital organs, okay. B is what bones look like when they have no calcium. Do you think this will help you? You will keep shape? No. And if they are soft and flexible, will they be able to protect your vital organs? Okay, I don't think so. Right. And then the last step is step 6, where we indicate, was our hypothesis correct or wrong? Okay, meaning that which you wrote at step 2. Is that what happened? Did the bones turn flexible and soft like you predicted, or did they remain hard or not? So there you write yes or no. Then B, is there something you could do to get better results? Give a reason for your answer. Okay, so in our case, actually thanks to COVID and the fact that our bones were in vinegar and water for 3 months rather than just a week, our results are quite spectacular. Okay, it is the first time in all the years that I do this experiment with my learners that they are actually this flexible. Usually they're just a little flexible, but because they've been in the vinegar for so long, almost all the calcium has been removed. All right. Apparently, if you do it with a much larger bone, like a turkey bone, then you can actually tie it into a knot. Okay, so here you say, is there something we could have done better? Did we do everything properly? Was this a fair test? Perhaps we did something wrong and that didn't make it a fair test. You write down for us there. So that was the bone experiment in a nutshell. Just a last view again. All right, so bones with calcium, and we compare them to bones without calcium. Nice and flexible. Okay, so I hope that this was fun. I tried. You are very lucky to miss out on the horrible smells, and you must have an awesome day.